Hi guys, there's another question from section 1.6, problem number 25. I already wrote the function. Now let me just mention to you, once you get to section 1.5 and beyond, you can just use the rules of differentiation. You don't have to always use the limit of the difference quotient, like last couple of videos. So just make sure you learn the rules so you can apply them because they're much quicker than using the limit. So I can see we have this is our function, capital G. So we do have a product of two function. So if you remember the product rule from last section, if anytime you have product of two function, I just label them little f and little g. It doesn't really matter the name. So as you remember, the product rule says derivative over product. So by the way, you do want to write that as a power because you can use, there is no rules for square roots. So we do want to write that as an exponent. So it's going to be x to the 1/2. So now we can use our product rule. So this is your first function. So you can think of it as your little f. And that's your little g, okay? So as you remember, the product rule says the derivative or product of two function is the first function. So that's your f. I'm going to write that again. And then times I'm going to put the derivative inside the bracket so you can distinguish between them. Times derivative of the second function. Your second function is g. And of course, g is 5x squared plus 3. So its derivative is just 10x. Because remember, derivative of constant is 0, 3 is 0. And derivative of 5x squared is 10x, which will come from last section, I believe, the rules. Excuse me, and then it's going to be plus the second function, the g itself, which again, I'll just write it again, 5x squared plus 3, and then times the derivative of the first function, f. So this is why you rewrote that as an exponent. So derivative of 8x, of course, is 8, and derivative of x to the 1/2 by power rule is 1/2 times x to the 1/2 minus 1, of course, 1/2 minus 1, which becomes negative 1/2, okay? So now this is pretty much your derivative. So the calculus is over. The rest is algebra. I'll go ahead and work it out for you to clean it up. So we distribute 10x times 8x, of course, becomes 80x squared. And then 10x times x to the 1/2 becomes 10. Don't forget x means x to the 2/2 because you can write 1 as 2/2. So if you do that, then of course 2/2 plus 1/2, which will add up to be 3/2. Because remember, when you multiply with the same base, you add the exponents. So 1/2 plus 2/2, which become 3/2. And then also we do a fold method here, 5x squared times 8, which becomes 40x squared. And then 5x squared times 1/2 becomes, first of all, 5 times 1/2 is 5/2. And then x squared times x to the negative 1/2 is going to be, don't forget 2 also means what? Same as 4/2. So if you write 2 as 4/2, so you can combine them with negative 1/2. 4/2 minus 1/2 becomes 3/2. And then also you go to second term, which becomes 3 times 8, which is 24. And then 3 times 1/2, which becomes 3/2 x to the negative 1/2. So again, as I said, this is pretty much algebra and little bit of arithmetic involved. The calculus was pretty much over once we applied the product rule on the top, but either way, we'll clean it up a little bit more. So you have 80 plus 40x squared. Those are like 10. That add up to be 120x squared. You have 10x to the 3/2 plus another 5/2x to the 3/2. Don't forget 10 means what? 20/2, because remember, you want to always combine them. So I'm just going to write 10 as 20/2 so we can add the fractions. 20 plus 5, of course, becomes 25/2 times x to the 3/2. So we just combine the like terms. So we already combined those two. We combined these two. Now you have the 3/2 x to the negative 1/2 also remaining there. That doesn't combine. And then also plus 24. Okay, so that should be your final answer after doing the calculus and all the algebra. Okay, so I'm just going to box that for you. So there is your applying the product rule. Okay, I hope that helps.